Hi, so we're going to share my screen. Um, Here we go. Okay, so the first place that we are going to look at is the Mid-Atlantic Bridge. I misspelled it. Hopefully it will still come up. Okay. Okay, so the Mid-Atlantic Ridge is about 3 kilometers wide. Let me just zoom out. Um, so it's about 3 kilometers above the ocean floor and about 1,000 to 1,500 kilometers wide. Um, it was first discovered in the 1950s. Its discovery led to the theory of the seafloor spreading, and it led to an acceptance of Wegener's theory of continental drift. Let's just zoom out a little more. So you can kind of see it going this way. But it separates the North American plate from the Eurasian plate in the North Atlantic, and the South American plate from the African plate in the South Atlantic. It is continuing to grow at a rate of about 2.7 centimeters per year in the east-west direction. Most of the ridge is underwater, but forms land as a set of volcanic islands. Some of these are Jan Mayen in Norway, Iceland, the Azores, St. Helena, St. Paul's Rock, and more. So let's just look at the Azores. I think I'm saying that right. So if we just zoom out, we can kind of see the ridge and where that formed it. So we can see the ridge coming through like that. Okay. So I have a little video about the Mid-Atlantic Ridge. Also, this is a map of it where it all goes through. Or just obviously not all of it, but a lot of it. So here's a little video.
While some plates crash together, others tear apart. It happens under the ocean, like here, in the middle of the Atlantic. Lava erupts at the boundary between two crustal plates, sealing the tear. This is the Mid-Atlantic Ridge, a 10,000-mile tear on the floor of the Atlantic Ocean. The ridge is a line of underwater volcanoes, and it's here that new oceanic crust is formed. It stretches from the South Atlantic all the way to Iceland in the north, where it rises above sea level. From the air, the Mid-Atlantic Ridge is an awesome sight. This dramatic scar in the landscape marks the boundary between the North American crustal plate on the left side and the European plate on the right. The gap between ocean plates is filling in at a rate of an inch a year. Part of the restless movement of the Earth's crust that's reshaping our world.
So I forgot to mention before the video that this rift demonstrates plate divergence, which is plates moving away from one another or rifting within a major plate. It's usually marked by new crust rising and shallow earthquakes and volcanic activity. And these islands all the ones I mentioned and even more, are formed by magma coming up and creating new crust and pushing away plates from one another. Okay. So the next place that we're gonna look at is Mount Everest. So as this loads, we'll take a look at it. So this is the top of Mount Everest. So Mount Everest is part of the Himalayas in southern Asia on the border between Nepal and Tibet. Let's just zoom out a little bit. And it reaches Mount Everest itself reaches an elevation of 29,032 feet. You can see it's pretty big, and here's Nepal. But in Tibet, they call it Goddess, Mother of the World, or Goddess of the Valley. The Himalayas themselves were created by tectonic movement as the Indian Australian plate moved northward from the south and was subducted under the Eurasian plate. So we're just going to zoom out a little bit to get a better view of all of the Himalayas themselves. But Everest and the peaks around it are a part of a large mountain massif that forms a focal point of tectonic action. And the two plates that I mentioned before were collided about 40 to 50 million years ago, but the Himalayas themselves started rising about 25 to 30 million years ago. This Everest is still over here, but we're just gonna look at the other parts of the Himalayas. You can see this isn't even all of it, but they're really wide. But Everest itself is composed of multiple layers of rock folded back on themselves. Higher up are found sedimentary rocks of marine origin from the ancient floor of the Tithe Sea that closed after the collision of the two plates. And this kind of convergence is continental. The continental crust is too buoyant to see. You can just see all of the Himalayas here, but the crust is too buoyant for much subduction. This is why the huge mountain ranges develop, and volcanism is rare. So I have a little video just about the formation. Okay, so that's it for that. So the last place we're gonna look at is Yellowstone. Um, Here is the caldera of Yellowstone. So you might be able to zoom in a little more on that. But Yellowstone is a hot spot, and the intense heat generated by it causes melting of the crust, which forms basaltic and rhyolitic magma. So rhyolite is high in silica, which makes it vicious and prevents gas from escaping. And when large amounts of it accumulate, large eruptions can occur, which is why this is kind of dangerous. But Yellowstone the hotspot itself has a history of explosions or eruptions, not explosions, And a tract of caldera stretches from northern Nevada to eastern Oregon to Yellowstone Park. So I'll just show this quick picture where you can see. But the oldest caldera erupted 16 million years ago, and the calderas get younger to the northeast, with Yellowstone being the most recent at 631,000 years old. The hot spot is within Earth's mantle, and the tectonic plates that make up Earth's surface move over its top. The North American plate is moving to the southwest at about 2.5 centimeters a year, and the Yellowstone mantle is suspected to be a mantle plume. Mantle plumes originate from the boundary between Earth's mantle and core, about 3,000 kilometers beneath the surface. Evidence for a plume beneath Yellowstone has been difficult to identify. The chemistry of helium gas released at Mud Volcano near Hayden Valley in Yellowstone National Park is indicative of a deep mantle origin, but that evidence is not conclusive. Mantle plumes are the rise of magma to Mantle plumes are the rise of magma to surface in the interior regions of a plate. Often the hot spot stays in place, but landforms move within the drifting plate. So that is all I have.